And today I'm going to be talking about CSA, Computer Software Assurance, which I don't particularly like the name of because it actually focuses about computer software, where really it should be about the solution. And everything that I talk about with MTP4, you know, you might have heard of Industry 4. There's a big push for Pharma 4.0 out there, the fourth revolution, industry revolution. Really, it's bigger. Well, it's actually bigger than, MedTech, biotech, and pharma. But, we've got regulations that sit over the top of, what we need to do. It's actually applicable for any industry out there. So a lot of the stuff I'm talking today to you about is generic across all industries, and we'll just make it focused towards MedTech. As it says there, I'm passionate about process optimization, which I put in when I put these systems in. So here's ISPE Pharma 4.0. I don't know if you know of ISPE, but they have this framework where they have working groups around the world that are looking at this topic called Pharma 4.0. And really, it's a misnomer, because really, it's if you see that and you're in the MedTech industry, you probably think, well, it's not applicable to me. But it's equally applicable to anybody. I was just talking to Tim, offline before we started this about what is it? And a lot of people don't know what it is. It's really a holistic view of your whole business. And so it involves all your processes. And when you go out there, people think it's just the latest technology. You put in some Internet of Things, using 3D printing, robotics, all this new technology. They're enablers in the overall scheme. And once you sort of realize that pretty much with tech these days, anything is possible, you're only being governed by the constraints you're putting on yourself, then your whole mindset sort of changes about what you can do. And you look at your problems. I know problems that come up with me these days, I'm looking at them in a different light. Somebody's got their microphone on. So if we could turn off the mics, that would be great. I'm getting a bit of feedback. Anyway, so today I want to concentrate on the validation 4.0 because that's the computer side of things. But initially I want to touch on the plug and produce side of things. But just be aware that this whole Industry 4 is a holistic view of your processes, using technology as a driver to help you change the way you do things. And a lot of things are procedural. You're doing things in a procedural way. Why do we do that? Because we think the regulations say we need to do this. Well, I've been speaking with the TGA, and they're on board about, being collaborative in this whole space, about working with industry to try and, not change the regulations, but change maybe the interpretation on what you need to do. Okay, so software with medical devices. So there are three main areas with this, and that's software that's used in the development of a medical device. And so these things are your, project lifecycle management systems, your manufacturing execution systems, any sort of computer systems that you use now. And a lot of you people are probably using the, the Atlassian suite of products, Confluence, Jira, etc. They fit into this scheme of things. And when CSA first came out, and I'll talk a little bit about CSA on the next slide, it was in this space. It was supposed to be for, and so you can see this is equally applicable to med devices, biotech, pharma, anybody, because we all use these computer systems around the outside of our processes. Within medical devices, we actually have software within a medical device, and these days we had software as a medical device. We all know what software in a medical device is, and probably most of you know what software as a medical device is as well. It's those apps and programs that are not actually implicitly involved with a medical device, but take data, whether it's from the device or whether it's from your own, body or whatever, and then use that to make decisions that then drive you to go back and use the medical device in a certain way. And those things are now being classed, depending on the risk, as with everything. This whole thing is risk-based. So I'm going to talk a lot today about risk. But a lot of us do risk assessment, but do we really use it correctly? Do we do the risk assessments at the right time? And then do we use them to justify, the amount of work that we do downstream? I just want to touch on...
Ben, sorry, I was just wondering if you could go back that slide. I'm just interested in you mentioning Jira. We use Jira at our company, and I know that software tools need to be validated if they're being used in the design of a medical device.
Yes.
And that I've heard rumors of that can even go down to validating Excel, itself. To what extent do companies need to worry about, which tools? Like, are you going to validate your Gmail and how far do you go in terms of validating the tools that you use to design a medical device?
That's the $64 million question. You're right. How far do you go? And it's to do with risk. And there are different classes of systems out there. So this Excel is classed as a GAMP category 3 system. So it's in, major use in multiple companies around the world. And because of that, you can use that you don't actually validate Excel itself. You validate your implementation of Excel. So the macros and the formulas that you use within Excel for your particular use. So using, and that's a very good point, because this whole thing comes back to the risk assessment. So you're not validating this, well, you're validating the software, but the focus needs to be on the process. And everything that I talk about today and the forum I'm going to talk about in a couple of weeks' time is going to be about your process. Where people get themselves into trouble these days is they focus on computer systems, where really the focus is on the process that computer system is automating within your company or within your device or whatever you're doing. And it's the risk of that process and then the individual functions within that process, whether they fail, because really you're relying on the computer system is the control over all your processes. If that works correctly, then that's the control over that component of the process. So really the risk should be, first of all, at a macro level, and I'll talk about macro risk in my talk today, about looking at, your Excel system in general, and then what are the individual processes within, which calculations, which ones of those are critical. Everything that I talk about is actually know your processes, know your data maps. Now, where is your data coming from to make the decisions? And then within your process, what are your critical control attributes? What are the key aspects of that process that affect the outcome of the device, of the process, whatever it is? If you can define what they are, and then you can define the critical process parameters around it, so the control parameters, so what, temperatures need to be kept within a certain range, humidity needs to be kept, time needs to be kept within a range. If you can define that and then put controls over those, then the rest of the process sort of falls out. And this is the trouble with validation. We've actually looked at everything when we come to do our test is 100%. So with people write these 200-page test scripts and then they run through it, and some of those bits of the test are really critical, and there are other bits that, prove that the screen moves from screen A to screen B, but they're taking the same intent of the testing, because once you give the test script to somebody, it's just 100% relevant, and we're just going through them, ticking them off. Yeah. The whole focus is to change about, well, what are the real key aspects? Focus your testing around the key aspects. And this is what the regulators really want to know, that your processes, what your device is being used for, what the critical control attributes are to make that work correctly, what the process parameters are, and you've focused your effort in your testing around those areas. And the other bits, yes, you want to see them work, but you don't have to spend the same amount of time on that. So what this is what CSA is all about, trying to give you back more time. And people think that CSA is about less testing. It's not. In my world, it's actually about more testing. It's about less documentation around the testing. And I've got some slides coming up that actually go through the amount of effort that we spend in not the testing, but the actual documentation. We kill ourselves with documentation and we don't spend our time on the right things to do with the actual testing.
Okay. I'm just going to encourage people to ask questions other than me. The person who asks the most number of questions today will get this lovely mug, which if you can read the words there, I don't know if it's going to go in focus or not.
Not really.
But it's
Weeks of coding can save you.
Weeks of coding can save you hours of planning. So it's a very sought after mug, this. If I ask the most number of questions, I'll probably get to keep it. But
that's tongue in cheek, obviously. Tongue in cheek,
Yeah.
that one, because the planning is the key point of all of this.
Obviously, yes.
Yes.
Anyway, yeah. So if people do ask questions, I'll ask you to keep the answers relatively short, because otherwise we won't get through all these slides. Okay, let's go.
I can give you a tip. We're not going to get through all the slides anyway.
Okay.
Anyway, so I wanted to talk a little bit about, so within medical devices and with other systems these days, you may have heard of the term machine learning. Some of you may be very familiar with this, artificial intelligence. Is there such a thing as artificial intelligence? Think about the way you learn, and it's learned by repetition, reading, knowledge. It's the same things that we're using to train computers up with. The difference is people forget things. Computers can remember and keep going. That's why we can make computers smarter than people, because we can forget things. Computers can keep remembering things. You may have heard of the term machine learning. You may not know what that means. I'm not going to obviously go into that much detail about it, but you see the little picture that I've got there on the slide. Machine learning really knows nothing about your process. It knows about great pools of data. And then what it does, it tries to map lines of best fit through the data to come up with algorithms that, match the actual data. So it's not predicting on what you think the system is going to do or the device is going to do. It's what it actually does do. And so it's taking, and lots of us have got reams and reams of data, and you can see there the different algorithms. If you just draw a straight line through those points, the least square comes up, linear fit comes up with a number of 413. But if you come up with that fancy sine graph there, you've minimized the amount of difference between the variation between the points. Now, this is what machine learning is doing. It's taking individual data sets, coming up, building its own machine learning rules, and then it's bringing in other pools of data. Like, you may not even know that temperature or pressure affects, the quality, but when you bring it in and you start to let the system do its work and start seeing it, it might come up with algorithms that say if the temperature's between 20 and 22, this happens. If it goes outside of that, the product starts falling off the rails. And so it's gathering information. Now, the benefit of this, it's multifactored. I'm not going to go through the benefit of this today. I'm going to mention it a little bit in the forum that I'm talking about in a couple of weeks' time, but just be aware that within medical devices, and I've given you a link there to the FDA, and there's like 340, there's a lot more devices, but there's about 343 that are registered on this particular website of medical devices that have machine learning registered, as part of their operation. And I'm sure a lot of you out there are actually using machine learning and artificial intelligence, within the development, and your particular devices. That's all I want to talk about at that today, because I really do want to get on to CSA. And CSA actually came about through the medical device industry. It actually came out in 2011 for this case for quality. And it came because industry was going to FDA and saying, we can't implement the latest technologies because of the validation that you guys are forcing on us. And the FDA was saying, we're not forcing this on you at all. This is your interpretation of what we want. And so together, they've come up with this. And as I said, I don't really like the term because it says software, where really it should be about solution, because everything's really about knowing your process. And so it started with the medical devices, but when the pharma and the biotech got wind of it, they said, hang on, this is equally applicable to us. And so it sort of got pushed back. So the FDA have not released, their guidance yet on this particular topic. ISPE, which is the GAMP forum, which you may or may not know of, they have released some guidance on this. And I've mentioned the document that it's in. Hopefully it makes sense when I'm talking to you about it. In the past, a lot of us, I talk to people about, when I talk to you about computer system validation, what do you think? And I get this, oh, gee, I don't like it. It's just an overhead that the QA department or the validation department put on us to create documents. It's not adding any value in a lot of the documentation. If that's the case, then you're not doing it correctly. If you're doing it right, then the CSV should be an enabler. And this is what when I train on it, and I do training courses on these topics I'm talking about, I try to change the mindset of people who come on my training. Yes, I tell you about what you need to do and why you need to do it. But in the end, I'm trying to change your mindset about seeing CSV as an enabler to put out quality products. So CSV is it's not just trying to create documents. In fact, that's just the output. The actual validation is the actions that you perform to gain knowledge, first of all, about your own processes, and then about the computer systems that you're using within, those processes. If you change your mindset and you get everybody in your group to do the same, it becomes you can make this become an enabler, and people actually do the work rather than forcing people to do it. Right, so CSA is really CSV done correctly. And the three areas that they focused on when they brought it out was risk assessment. And I do want to talk about risk today because risk is all encompassing. There's not just one area where you do risk. You need to continue doing this throughout your projects. Critical thinking. Now, that's big within this industry 4.0, getting people to think. And I gave a talk recently to ISPE over in India, and somebody asked me, Ian, what's the difference between this critical thinking you're talking about and conventional thinking? And I had to think about it for a moment, and I came back and I said, well, conventional thinking is probably not thinking at all. It's just taking the current standard operating procedures, policies, work instructions that you have and following them through that you've done for the last 5 years. And because your policy says you need to do this, your procedure says this is the way we do things, this is what you do. Critical thinking is taking a step back and making those requirements a little bit more grayer and giving you the opportunity to justify why you do things for each particular application. So focus is on that and vendor collaboration. So we all work with vendors. The vendors do a lot of work, a lot of good work. If you're buying software, we spoke about Excel before. Think about any software that you use, what we should be doing is placing a lot more emphasis on the testing that the vendor has done so that we focus our work on the bits that we change, the configurations that we make, the customizations that we make, and we rely on the vendor's documentation to actually support that. And CSA is all about that. I'm not going to go through this big definition of CSV, but really, I want you to be thinking that CSV is really just ensuring that whatever the software solution is, that it works reliably and consistently throughout its life cycle. That's what the aim is. All right, so now I did want to mention, ISO 62304, which you guys are probably quite familiar with, the standard for software lifecycle processes in medical devices, because in there, it goes through some of these phases. And for every device, it has planning requirements, system testing and release as part of, mandatory things that it doesn't say the level you need to do it. And that question before, how much effort do we spend? Well, having a good risk assessment approach helps you to determine that you spend a lot of effort here and not much effort on this system. I like this slide because the bottom line there is in standard projects, computer system type projects, these are the generic sort of time frame ratio splits that people take for the different phases of a project. Now, you can see here there's 35% in testing. When we get into our environment, this is the time taken. And it's not just a matter that we're taking more time as a ratio split. We're actually taking more time as a length of a project because we have put these validation constraints. So in other industries, it may take 30 days. We may be taking 50 days to do the same thing. So this really means that we're actually spending almost twice the amount of time in the testing phase, typically on projects. What's that telling us? It's telling us we're trying to build quality in by testing it. You can't do that. That mug that Tim's put up there is actually quite a good tongue-in-cheek thing. Let's do more coding, more testing, and try and find the bugs. Whereas if we took a step back and found out that if we designed things up front in a better way and did a bit more analysis and spent our time there, we could actually spend less time because we'd have less bugs to fix in the first place. So this is a very good slide to sort of say that we've skewed our thinking towards testing quality in, which is the wrong way of doing things. I've been speaking a bit now. Has anyone got any questions? No? You're on mute, Tim. What of agile methodologies? You're on mute, Tim. I can't hear you. Agile methodologies. Very good point. Yeah, it doesn't matter whether you're using a waterfall approach or, and most people these days are using agile. And, hopefully, and it's about, agile is not about a prototyping. I've seen people use agile like a prototyping approach where they'll go off and try things for 2 weeks, come back, that didn't work, let's try something else. Agile still relies on you having a list of requirements, a priority list of requirements, and then updating that list so that you can put it into sprints and do 2 weeks of work or whatever. There's no reason why you can't overlay a validation methodology on top of your agile, because agile is a development methodology and validation is, putting quality over the top of that. So at the end of any sprint, you should have up-to-date requirements, you should have design documents, you should have test plans, and that part of the implementation that you've just done should be tested. So as long as you've got a good discipline that you can put over the top of your agile methodology, I have no problem. It's just that I've seen agile go off there as like a prototyping, and they've started agile even before they've got requirements in place. In your experience, have you encountered regulations rejecting agile approaches in spite of having indeed good discipline? No, I haven't seen it if they've got good discipline, because good discipline means that they're doing the things I'm saying about, talking about. Yes, I've seen them being rejected because they haven't got good discipline, and so they don't have, that discipline of keeping that documentation up to date. Look, the regulators, and I've been speaking with them and working with them quite a bit recently. They really want to work with industry. They don't want to come in there and just, tell you that you're doing things wrong. They actually do want to work with you. If you've got a good methodology and you can justify your approach, then you should be able to defend that. And an agile methodology is actually a really good approach if you're using it correctly, because you're having, the problem with the waterfall approach, is that you did all your requirements, then you did all your design, then you didn't see people for weeks while they were off doing it. Then you came back and it was a game of like Chinese whispers, where you sort of thought you were getting the right thing and then something would come back and it wasn't what you were expecting. Whereas if you've got really using agile correctly, you're having regular meetings. And that's what this is all about, a good communication strategy, and that whole MTP4, one of the things was management communication strategy, and so having a good communication strategy that sits over the top of your agile methodology is actually an excellent way of doing things. So verification and validation. Yeah, very good. So you do have this verification. In our terms, if you map it to like a pharma type approach, they have design. Your validation is really the testing at the end. So if you see the testing here, you're talking about validation, and your V and V is like little V's, and where I'm talking about the verification is like design qualification, which I'm going to talk about. And that's the mapping of requirements through to designs, through to tests. So, and that's your verification. And in the medical device space, your validation is really our testing, our end user testing at the end. So yes, people get confused and you think I'm talking, really at the end of the day, whether you're pharma, biotech, medical device, it's a process. At the end of the day, we're automating a process. I don't care what the terminology is, as long as we do understand what our differences of terminology is. And I do go through verification and validation as part of my training course and map that back into design qualification, just making sure that has the system been built right? That's the verification. Has the right system been built? That's the validation. And so if you can think of those two terms, it's easy to map the two things together. I realize I'm halfway through my talk and I haven't really even started on CSA yet. But anyway, hopefully this is useful to you. And I'm happy to answer any questions as we go along. This is a V model, which you may or may not have heard about before. This is what GAMP has put out, and the whole pharma community uses this pretty much as a Bible. And you'll see this on vendors' websites. to me, it's a little bit confusing because we've come up with these terms, these qualification terms. In our industry, a lot of people don't know the difference between validation, testing, and qualification. And I've got a slide coming up that shows you the difference. And just in your mind, it helps to know that. The problem with this is they had that user requirements, which is the English what the system or device has to do. And the design is how the software or whatever it is will actually automate those requirements. And then there was this gray area in the middle of functional requirements where you sort of got your vendor to sort of tell you and bridge the gap. To me, that's a little confusing because there's this blend of requirements that sort of fits in the both here, and then a blend of design that sort of, so this is people are always confused about this middle layer of documentation. When I'm doing CSA these days, I'm pretty much only creating two sets of documents, one which is requirements and one which is design. And I don't need to split it into these three spots. The only reason I would do a user requirements is if I don't know who the vendor is up front and I want to put down a scoping document that I can send out and get some information back. But in the end, this is like a 1 hour presentation that I could give you on its own. So if you understand, this is a full makeup of how you do computer system implementations. And really, it's just good engineering practices. On the top of this, you would have a validation plan. On the bottom of this, you would have a validation report. And then for each one of your systems, this is a worst case situation where you do different levels of testing. At the end of the day, as I said, this functional requirements is what the system has to do. The design is how the system has to do it. This whole thing here is called validation. This whole right-hand side here is called testing. And this whole top box over here is called qualification. And we have a lot of people who don't understand the differences of those things. So the whole thing is looking at the holistic view of what your device wants to do or your computer system needs to do. Testing is about the vendor being involved with doing some of this and then handing it over to the end user. And the end user, whatever the end user does, is about qualifying it. And, and we qualify processes, we qualify people. It's taking what you've got at a point in time and making sure that they're fit for purpose. That's what qualification is. Whereas testing is looking underneath the hood a little bit as well, and and looking at the coding standards, etc., making sure it's been followed, and those sort of things. When it gets up to qualification, you just assume that those things have been done. So for each system, you need to decide how much effort that you spend on each one of these phases, and sometimes for very high or low risk sort of systems, you're just going to create a few requirements and come up with a few end user tests, and hopefully you've got a bit of design configuration in the middle, like for an Excel spreadsheet. What formulas are you using? So that you note them down. Now,
I think that mat is in my other office.
Okay.
And I haven't been in there because they moved us all.
Sorry, can I get everyone to mute, please?
I think it's one that was fully urban.
Hello, is there a question there? Oh, no?
I've just muted him, don't worry. Move on.
Okay, fine. So talking about that, I want to get onto the CSA. So if you've been involved in computer system validation, you will know that in a lot of cases, they get you to do a lot of documentation. There's requirements, there's functional risks, there's tests, there's requirements traceability matrices that you may create. With a CSA approach, what I'm trying to do is just bring it back to a requirements document and a design document. Within the requirements document, we actually I'm going to show you some examples, hopefully in a moment, where we actually embed the test cases. Now, GAMP has said all along, as we're doing requirements, we should be thinking about the test cases that support that. That helps us to refine our requirements. In so many cases, when I've read people's user requirements, they're not requirements at all. They're capabilities. The system must be user-friendly. The system must respond in a reasonable time frame. These are sort of things that you find in people's requirements documents. Now, you tell me what the test case is. The system must be user-friendly. How is somebody supposed to test that? So the benefit of forcing people to think about the test cases, and I'll show you a way of thinking about just having a mindset to think about this. actually refines your requirements so that you actually get better requirements up front. Because, you know, the things I've found in projects is that people put these fluffy requirements together and they hand it down the tree to somebody to go and develop their system for them. And then they leave it to the developer to interpret what they meant by that. And so they bring it back, somebody's happy, somebody's not happy. You know, what we're trying to do is, and when I've thought about it, people don't want to have that discussion up front, because it can get quite heated about what do you really mean by that. If we just say a system needs to do X, Y, Z, I'm sitting across the room from someone else and both of us are thinking, yes, it satisfies what we're thinking, but we're both thinking that it's going to be done in a different way. Have that conversation up front. You know, and these CSA is more like a framework of a set of tools to actually help you to build quality in your development process. So the good thing about this is we're going to build that in. We're actually going to do a functional risk assessment when we create our requirements, and then hopefully we can get our vendors on board, or anyone who's, you know, coding or doing the actual software development, to actually map those requirements down and do a level of testing down there. And I'll explain the different functional, you know, this is a functional risk assessment. Down here, we have a technical risk assessment. And if you use both of those together, you will get a better result. The benefit of getting your vendor or your developers to actually do a lot of the testing is that you can use that information to come back here and reassess your risks to maybe downgrade them. Maybe you're going to upgrade them, but downgrade the risks so that your end user testing, or the validation phase that you call at the end, means that you can do less because you can actually rely on some of the testing that's been done in line with the development. When I show you some examples, hopefully this will make some sense. So I've just got a quick slide here on risk assessment. And this is like that V model that I was showing you before. When you're developing a system, you know, or whatever you're developing, then there's a major project here. And then each change, when you come along and you do changes to your systems or changes to your device software, there'll be many little projects that you're doing along the way here. You know, so there's risk assessment at the start. And I want to go through that one because it's important to be able to rank or rate your systems within your organization relative to each other, which will help you to determine the amount of effort that you can justify that you spend on each one of them. And really, this is what the regulators are looking for. They're looking for that you know your processes. You know that this system, this Excel spreadsheet, really is not as important as your, you know, project lifecycle management system that you're using, or some of your, you know, Jira software. That's whether that's important or not. You need to determine that risk. And then we've got a number of other risks. You know, when you're actually writing your requirements, have we written ambiguous requirements? Have we got them complete? When you get down to the coding stages, is this a new technology that we're using to develop our software or our device software? You know, for testing, testing's a good one because you look at the risk. If you're given a week to do testing and there's a lot of pressure on you to get something out the door, you don't want to find errors. And so you approach your testing with a different mindset. You're actually testing for success. And so anybody on the call here that actually does testing, can you say whether you test for success or do you test for failure? You know, do we want to see the system pass, or are we actually putting tests down that we actually are really pushing it? Because there's a lot of systems that they tick the box that the validation's been done. We have the party that the system's gone in successfully. The first week, errors come up. We need to call the vendors back to help us fix it up. It's a scary statistic, but it's about 70% of computer software projects are classed as failures. So if you think about that, why do so many projects fail? And there are a lot of reasons for failure. There's only one reason for success, that you've captured all the failure points and you've mitigated them as you go along. And some of the techniques that I use for this CSA approach actually force you to bring in mitigations. And the earlier, you may have seen some slides on the cost of computer system failures. You know, if you find the fault in the first phase, it's $1. If you find it in the second phase, it's $3. If you find it in the third phase, it's $9. It's like a 3 every time it's going up. If you find it out in production, you know, it's some huge cost that, you know, to bring the system back Yeah, someone said me testing is trying to break things. Well, yes and no. You're trying to see that your system works, but if you're doing full testing for trying to push the system through its paces, then yes, you are trying to. That's great, that thought, but not everyone tests in that way. If you've only given 3 days to do testing and there's pressure on you to get something out the door, or a system has to go on, people are not thinking always in that light. People are just trying to tick a box to say that testing's been done. In the perfect world, you're correct. Testing should be trying to find the faults, but it's a mindset of the tester and the conditions that you're doing your testing within. So there's a lot of things here, but if we go through here, I want to really get into the initial risk assessment. So when we spoke about Excel before. How do we rank Excel compared to a PLM or Jira or Confluence or whatever other software you're using? If you look at some readings out there on the internet, they just use this thing called a GAMP category. And GAMP came up and they came up with this grading. For category 1, they were like operating systems. Things that are used within software, but they're used in hundreds of thousands. Software in pieces of equipment. Probes, testing probes, temperature probes, pH probes, whatever. They've all got EPROMs and software within them. They're sort of category 1 type systems. So testing the application themselves implicitly tests the software that runs within it. They have non-configured packages, of which Excel is one of those. Those that are in prolific use across the marketplace, so much so that you can say that I don't have to test the software, I've only got to test my implementation of it. Now, why are we a very conservative industry? It's because if we take the latest version of Excel that came out yesterday, then we cannot put our hand on our heart and justify that that's in 10,000 companies around the world because we're the first ones using it. So typically we're lagging behind, in a lot of softwares and technologies. And you can have a look about, what version of software are you running on and what is the latest version. In a way, SaaS, software as a service, and the hosted cloud systems have sort of changed a bit of that, because these days we don't get a chance to say we're not going to take the latest version. If we're on a SaaS environment, it's just put on for us, every 6 months or every year. Whereas in the past, if we had on-prem type software, we would choose not to take the latest release because of the validation effort and things were working the way they were. And in a lot of cases, we only took it when it ran out of support contracts. And so it goes through the list here. So you've got configured products, which are most of the products that are on the marketplace. Your SAPs, any of your LIMS type systems, or anything that's out there that you configure and use. So, and then there's custom applications, which are, in a lot of medical devices or software that you're the only one pretty much in the world running. And so they've gone through and used this. That's only one class that you should use in the total, risk determination. Other people are saying, well, let's just focus on the risks of the product or patient. If it's a direct risk, let's validate it. If it's an indirect risk, let's not worry too much about it. Again, that's not a granular enough approach to do risk assessment. When I've looked at it, there's a lot, size, complexity, there's a whole lot of things. If you're looking at the holistic picture, you've got to look, and some of them are financial impact, and you say, well, why are we looking at financial impact? That's nothing to do with regulatory requirements. In a way, I think this whole GXP thing, and I'm told the TGA this, it's sort of clouded the industry a little bit. People think that if it needs to, for GXP reasons, good manufacturing, good laboratory, good clinical practices, whatever, it needs to be validated. And there are regulations that say what you need to do. But then they say, well, if it's not GXP, then it doesn't require any validation. There's nothing in a regulation anywhere that says just because it's not regulated, you don't have to do anything with it. And so I'm trying to change people's mindsets. So let's bring in a proper risk assessment approach, look at every one of your systems on its merits, and by inference, the higher risk, GXP systems will be higher up the tree anyway. So it'll force you to do more effort, but it doesn't mean that systems that are not GXP have got no risk to your business. Some of them are quite risky to you as a business, running your business going forward. And so I would argue that they require some level of validation and confirmation that they're working correctly. If you use a good risk assessment approach, and we work with companies using like an Excel spreadsheet, asking a lot of questions, and you can see here that GAMP category was one of them, and safety and efficacy here was one of them too. So if your system was a class 1 system, which is customer facing or product facing, so if that is, then it will implicitly get 60 added to it, 4 times 15. If it's non-GXP, it gets nothing added to it. If it's a class 2, it doesn't affect the product or the patient, but it's used in the creation of that product or whatever. And class 3 is if it's part of your quality management system. So, document control systems, change control systems, they don't have direct impact on the final product, but they have some indirect. And so if you were to go through and ask questions, and, when I do this, we're not just asking the end user, we're asking developers, we're asking IT people, and we're asking financial people, what are the costs of these? If this was to fail, what's the cost of the business? If that's high, then it'll raise the risk. If you can do this for every one of your systems, you come up with a number which puts it into a grading. So I like to do this, get an inventory of systems. So all the computer systems you're using, go through every single one of them, and then go through and do a risk assessment, and then you can rank each one relative to each other.
Yeah, this is very interesting because, as mentioned before, the idea of medical devices versus pharmaceutical processes. For those not familiar, GMP, good manufacturing practice, is a term used to look at all of the systems that are used in a production line from start to finish to make sure that the product is controlled. So whether it's a pill which comes out at the end or a living cell to be injected into a person, then you need to have good manufacturing practice. But I can see how this thinking could be applied. You might want to rejig this to designing an electronic product, but it's a little bit more holistic than some of the other approaches we've discussed in this community so far.
You're right. You're right. This thing would need to be, I've just put this as a generic type flavor. You need to rejig it for your industry. This is like a pharma type industry one, but you could rejig this, but you're not just looking at one aspect. It's making you actually look at all the aspects, including your business risk. And so I really think that's a really good approach. And then when we come to do projects, I'm not going to have a lot of time to do all this, but going through the validation, that's the key thinking document at the start, getting people involved. Yeah,
we have officially got about 10 minutes left. So okay, you might want to focus on the things you want to cover most in the remaining slides.
I will. This is well known. I don't know if it's well known it's well known in our industry because and I know you guys do failure modes and effects analysis and risk assessments and do lots of those when you're doing devices. So this would be well known. This is a typical functional risk assessment that we do, and I guess you do the same things as well. Now, the problem is I've always been wary about when you do this. People have done this after you've created your requirement. In fact, they've done it after you've done your design. I've seen people do this functional risk assessment the night before they're about to start testing. Doesn't add a lot of value if you're doing it the night before you're about to start testing. And also the issue is when you start finding these things to be high and you want to put in some mitigations to bring them down, you've got to justify it. Imagine if we were able to do this at the time you were actually putting your requirements together. And that's what CSA is about. This is both a functional risk assessment and a technical risk. And this is why people do it at the night before the testing, because they know about the software at that stage. Whereas it's really two sets. One of it's about the process, and you should do your risk assessment about the process when you're doing your requirements. Just is what if those scenarios when you're going through your requirements. And then when you know about the software, you do the technical risk assessment. Here's an example. I'm showing you one that I've done for like a document control system, whereas typically you'd see these are requirements and there's just lines and lines of requirements. In the CSA approach, I'm actually building all the test cases in. So think about that requirement, and then in your mindset, think about ensure that, use that concept, test that, ensure that sort of thing. and then think about all the things that you'd want to test about that particular requirement. Put them down here, and then you can come up, well, severity, likelihood, detectability, and then a risk assessment. And we've got an algorithm to work that out. So what's the severity if that was to fail? And in a lot of cases, it's going to be high, and you can't change the severity. All you can change is the controls. And so as you change the control, what's the likelihood of that happening? Well, before you know what the software is doing to control that, that might be high. After you know that that software does that out of the box, you know, and you don't have to change that, then that you may change that and downgrade it. If that was to happen, you know, how likely are you to detect that that fault was to happen before it went on and caused an issue? If it's got high detectability, then it'll lower the overall risk. And I mean, you guys might know all this about risk assessment. What we're trying to come up with is a set of risks for every test that we're going to do. And so what CSA is then going to say, only the ones that are high are we going to go off and force people to do thorough testing. You know, write a test script, take a screen print, those sort of things. Anything else, low or medium, I'm happy to use this document as the self-sourcing testing document to go off and do the testing yourself. So this document becomes the requirements. When we sign it off, it's also going to become your end user testing document. So it's more like a checklist where you're ticking off. And so this is what I'm saying. We're going to test everything. But in a lot of cases, we're not going to write any more documentation. I want somebody who understands, and this is the difference. In the past, companies have bought in off, you know, the gig economy. We just bring in someone who's going to do the testing for us. If we do that, then we do have to write the test script so a monkey could run it. What I'm doing is saying that if you use somebody who actually knows the intent, so, and you need to be able to show that that person is trained in the process and understands, then why are we not trusting that that person goes through and actually ticks a box and signs for it to say that they've seen it work? And so that's the whole concept, using people and the skill of people to actually justify why we don't need to do as much documentation. This is a traceability matrix, and you guys have probably seen this. In the past, we've created these huge documents which track your requirements in, and this is, you know, your verification process pretty much, how we track your requirements have got through your full process. In a CSA environment, because that's all inbuilt into the requirements document, we don't need to have a formal separate document because it comes out into the actual design itself. We've only got a one-to-one mapping. So there was functional risks. When we get down to the design stage, and that's the actual configuration or customization of the software, we need to work with the vendor or our own internal staff who are developing things to say whether that feature is out of the box, whether it's configured, so the software comes with it, but we need to tinker with a few parameters, or whether it's customized. That means you've actually written something with some coding language or, you know, in an API that comes with the actual software. Someone said here, I've been told in the past by regulators that detectability was not acceptable to evaluate risk levels. I haven't heard of that. You have to be able to justify it, not on its own. You need to be able to put together with the severity, the likelihood, and the detectability, but you need to be able to justify how you've come up with, you know, it's got high detectability or low detectability. So I haven't seen that hasn't been accepted if you can justify. In fact, I haven't really seen anything if you can justify your approach. And so in here, this is another table that we can come up with to talk about. And you can see here, only those ones that are really high and customized or configured will need a test script. All the others, we can work with our vendor to make sure that the vendor has just justified and tested that works. The more testing you can do at system testing, the less testing you need to do at user acceptance. In a perfect world, you'd be working with your manufacturers or your developers to actually do a lot of the testing. We don't live in a perfect world. In a lot of cases, people have already bought software, the vendor is not going to do any work. In that case, you have to go back and do a full set of user acceptance testing at the end. I'm just trying to tell you, you know, you need to be able to tailor this for different conditions. So, as I said before, you've got the requirements in your requirements document, you drag them through into your design, you say whether that is, you know, configured out of the box, whatever, it comes up with a risk assessment down there. And so if your vendor's working with you, they can do some testing down at that level that matches the exact testing that you had back for the requirements that you had at the functional level. Then you can go back and reassess your risk. After they've tested it, you might say, no, that's not as high a risk as we thought. You know, the final testing has brought the risk down. All this, all this stuff needs to be justified as you're going through your process. Then your test plan really just becomes, remember, you've got this big document with a whole lot of tests in it. The plan becomes a framework for how you're going to drill through and which order you're going to do them in. Just to sort of finish this off here. So you've gone down here, you've got your test places, then you actually use this up here to come back and do, in a perfect world, you would have your vendor doing a lot of testing, justifying that to come back here and upgrade or update your documentation. And then you would come up with a set of user acceptance tests. And again, this is good because it becomes a regression. So the first time you do it, you're going to test everything. In a year's time, you get an upgrade, you make a few changes, you come back to this document, you've only got to pick a subset of the particular tests, but it becomes the self-sourcing testing document. In the past, we've found that people keep test documents up to date. They don't necessarily keep requirements and design documents up to date, and people have been pinged in audits for that. The beauty with this is it's actually forcing you to go back because they're all in the self-contained documents. It's giving you more opportunity to keep your documentation in line with your device or your software that's supporting your device. So the conclusions on CSA, I like it because it's going to force people to actually get involved to talk about the systems up front. So to think about what the system should be doing and then to develop positive and negative tests to use against them. It forces continual risk assessment in line with your requirements and your design. It actually sets this ratio back of quality, adding between validation documentation and actually actions back into where it should be, that we're not just creating documents for the sake of it. We're actually only creating enough, and we're spending more time on testing than we're spending on the actual documentation. That's what I'm trying to achieve. You might read some readings that CSA says it means less testing. I'm actually saying it probably means more actual testing time and less documentation around it, because you all know the amount of time taken to fix test scripts, to write deviations, discrepancies up, to fix them again. And everything that a lot of the talks I've been talking and hearing lately about this MTP4 is all about autonomy. People wanting to feel like they have more control over the process and giving people the opportunity to have more control over their own destiny. So what we're trying to do now is empower people. So validation is not just the validation or quality team. It's actually everybody on the project is involved in this. So we want the validation team actually, rather than doing the validations, to become mentors for actually the project people. And we start meshing the actual project and validation together. So, we're not thinking that validation is a separate task.